Now we'll look into some of the applications where some of the problems can be solved using stack operations. One of such operations is parenthesis checking or validation of the parenthesis. If you talk about a well-formed formula, then the formula can involve nested braces or brackets. Now, whenever we want to check whether the expression is correctly parenthesized or not, we can automate this using stack. Here the idea is very simple. We'll initialize a stack and scanning from left to right for the expression. Whenever there is a bracket is encountered, character of bracket is encountered, then we'll push that into the stack. Here brackets may be of different types. Whatever be the type, just whenever there is a opening bracket, then we'll push into the stack. Apart from the bracket, if there are any other expressions, just we'll skip them. We don't push into the stack, just we'll skip them. Now, if we keep on doing this, at one point of time, all the left openings of all the brackets will be pushed under the stack. Will we keep on pushing them. Now, once there is a right end of any of the brackets is encountered, then once it is encountered, then we match with the top element of the stack. If the right end type of the bracket matches with the top element of the stack, which should be the left end of the similar kind of bracket. If they match, then we'll pop out that left end from the stack. That means one of the matching parentheses, right end of the matching parenthesis has been encountered, and we can remove the left end of that. So like this, if we keep on moving, sometimes we may push the left opens of the brackets, or sometimes we may encounter the right closings of the brackets continuously. So until the expression is completely scanned from left to right, we'll keep on doing this, pushing the left opens, and whenever right closed is encountered, pop out the corresponding left open brackets. So if we keep on doing this process, three cases may arise where by the time the last right closing is encountered, and if we pop out the corresponding left open, and by the time the stack is empty, that means all the left open brackets are being matched with the right open brackets. That is one case. Or the left open brackets are exhausted in the stack, that means stack is empty, but there are some more right closing brackets are left in the expression. That is one case where it is also imbalanced because the numbers are not matching. Or the other way around, the stack may contain some of the left open brackets, but the expression has exhausted. That means there are no matching right open brackets. In that case also, the expression is not balancing. So like this, we'll observe the cases and we'll follow through in the form of an algorithm. Here we see an example. There is a series of left and right opening and closings are there of some expression, and let us try to see the stack behavior. If the first one is a curly brace opening, so we push it onto the stack, and then the square bracket opening is there, next one, again we push it under that, again another open bracket is there, left open, so we push that, another curly brace, push that. So whenever there are left openings, we keep on pushing. Now the fifth one is right closing. So here the right closing is a curly brace. Then we'll immediately look into the topmost element in the stack. The topmost element incidentally matches with the same type of bracket, which is a left open of that. So we'll pop out that curly brace which is at the top of the stack at that point of time. That means the bracket is matching. Then the right closing is there. Again, right closing is also matching with the topmost. We take out that, and again at this point of time there is a left square bracket. So we push it onto the stack. Again, right bracket is there, right closing is there for the square bracket. We pop out the topmost left square bracket opening. Then another square bracket closing. So again the topmost element in the stack is again left closing of the square bracket, so it is matching, so pop it out. And finally the curly brace is there, which is closing. which is matching with the curly brace, which is the left hand side. So by this time all the brackets are over in the stack and in the expression also. So it's an indication that all the left openings are exactly matching with the right openings, and the expression shall be perfectly balanced. In the evaluation of the expressions, when the expression is perfectly parenthesized in all respects, then no problem with that. The innermost parenthesis will be operated, and then the outermost like that. But sometimes even if the expression is not parenthesized and expressions is involving some of the operators, still we can process that by using operator precedence. So first let us try to understand the operator precedence here. Usually the multiplication and division are given equal priority. They will have the highest priority with respect to the remaining ones. The addition and subtraction will again among themselves they have equal priority, but they are having lower priority when compared with star and division. And similarly, if there are any brackets, they will be given priority with respect to the others. They must be evaluated before anything that is to be completed. And in case if there are two expressions star and division, though they are having equal priority, when the resolving of operations among themselves is concerned, the associativity comes into precedence, and here the leftmost, the left part in the expression will have to be evaluated first. That means if A star B comes first with respect to division, then star has to be completed. Whereas if A division B star C is given, then division has to be completed. So that is how we resolve the precedence when expressions of equal priority comes in adjacent. To evaluate given arithmetic expression, that it is convenient to convert it into either postfix notation or prefix notation, which are two prevailing notations which are useful in the evaluation of the expressions. That becomes easier for us to evaluate. Now here we look into the postfix expression corresponding to the given expression. So in this case, what do we do is simply operator will be pushed to the right hand side of the operands. For any pair of operands, operator will be there in the middle in the infix, so that will be pushed on to the right hand side. So here if you look at the expression, given expression, 3 plus 6 is in the innermost bracket. So first we concentrate on the innermost bracket, and star will be pushed into the right hand side of 3 comma 6. So 3 6 star is the expression inside the parenthesis. So by treating this as single number, we have 5 star that number. So again 5 and that number are placed, then star is pushed to the right hand side. Similarly, we have 2 star that number is there, again 2 comma that number is pushed and star is pushed into the right hand side. Then comes division, 15 is pushed to the left hand side, division will be pushed into the right hand side of those two combinations of numbers. Then comes subtraction and 3 will be pushed into the left hand side, and subtraction will remain there. So this is how we'll create the postfix expression for the given algebraic expression. Now once we do this, simply we can evaluate this using a stack. So first initially we push all the operands onto the stack. So first we push 3, then 15, then 2, 5, 2 and 6. So by the time we push all the operands onto the stack, the first expression that comes is plus. That is uncounted. Then whenever the operator is uncounted, we pop out the topmost 2 elements of the stack. By that time 6 comma 3 are the topmost elements of the stack, so they will be popped out and then operated on them. 6 plus 3 is operated, that is again pushed onto the stack as 9. So 6 is pushed out, 6 is popped out, 3 is popped out, and then operated on that. 6 plus 3, 9 is again pushed into the stack. So 9, 5, 2, 15, 3 is the stack at that position. Once that is done, star is the operator. Then again the topmost 2 elements are picked up. 9 comma 5 are picked up. 9 5s are 45 is pushed into the stack. Again another star is encountered. 45 2s, 45 comma 2 are popped out. 45 2s are there. 90 is pushed into the stack again. Then division comes. So 90 comma 15 or the elements are popped out and the division is completed, 6 is pushed onto the stack. And finally subtraction, minus is there, 6 and 3 are pushed up, popped out, and 6 minus 3 is performed, and finally 3 is placed onto the stack. So simply first we push all the operands onto the stack. Whenever there is an operator, pop out the topmost 2 elements of the stack and operate them, and the resultant will be pushed again onto the stack. Simply we keep on doing this until all the operators are exhausted. In the previous slide, we have seen evaluation of the postfix notation, which is very easy. But in case of infix notation, given the expression is in the form of infix notation, that is operator is in between the operands, we need to look into the performance or processing a little bit closer. Because the expression directly involves a combination of operands and operators, they may be in between the operands and operators. So we need to be careful with that. So we need to set some of the rules for this. So first what we do is if the character is an operand, then push it to the operand stack. Here we initialize 2 stacks. One is for the operands, another is for the operator. So 2 stacks are maintained. Operands are pushed into one of the stacks and operators will be pushed onto the other stack. Okay, so if the character is operand, then push it into the operand stack. And if the character is an operator, and if the operator stack is empty, then push it directly onto the operator stack. If the operator stack is non-empty and you are going to push a new operator onto that, then we have to observe the precedence rules here. If the character's precedence to be pushed is greater than the existing topmost character of the stack, then push this character into the stack. So if the incoming operator's precedence is more than the topmost existing character's precedence, then push it onto the stack. If the incoming operator's precedence is less than the existing topmost character of the operator stack, then pop out and operate on the operators that are existing until the incoming character's precedence is greater than that. So this is a process that we need to do. And if the character is left open, then push it under the stack of operators. And if the character is right end, closing bracket, then again pop out the elements and operate until the left open is encountered in the character stack. Once the expression iteration is completed and the operator stack is non-empty, then operate until the operator stack is empty, pop out all the elements and operate on the existing elements with respect to the operators, and the value left in the operand stack is the final result. And when it comes to the operator, here we are using one word, operation. What is that operation is? Whenever two operands are there and one operator is there, the operation that we do is we'll pop out the top 2 operands from the operand stack, and we pop out operator from the operator stack and perform the operation of on both the operands and compute the resultant value and push it under the stack. So by mean operation here, the functionality of this is calculating the resultant value of C and pushing it onto the stack. This is how we process the infix notation. Let us say an example here. Given an infix notation, expression is given in the form of infix notation. Immediately we'll initiate 2 stacks, operand stack and operator stack here. In the operand stack, we push 2 into the operand stack, star is encountered, we push star into the operator stack, left open is encountered, we push into the operator stack, 5 is encountered, 5 is pushed into the operand stack, star is encountered, we push star into the operator, left open again, pushed into the operator stack, 3 pushed into the operand stack, plus is again pushed onto the operator stack, and 6 is again pushed onto the operand stack. Then comes the right closing. Once there is a right closing, we need to evaluate the expression. So until the left open is encountered, So pop out the topmost two elements 3 comma 6 and pop out the topmost operator plus and operate them. 9 is computed, 9 is pushed onto the stack, and then the left opening is encountered, left open bracket is encountered, that is popped out. That means the evaluation of 3 plus 6 is complete, and evaluation of the expression within parentheses is complete by the time. Now 9, 5, 2 are the operands now. Star, left open, and star is the operator stack at this point of time. Then star is the latest operator available. Then we pop out two elements 9 and 5 and operate them on that. So it becomes 45. 45 is pushed onto the stack. 45, 2, and bracket is there. Left open bracket is there by the time. And then right open is there. So corresponding left open is also picked up from the operator stack. So 45, 2 are left. Once that is left, then the next operator is division. Division is pushed onto the stack. Then because it is having higher priority than star, it is having equal priority of that of star, so it will be pushed onto the stack. Then 15 is pushed into the operator stack, operand stack. So 15, 45, 2 are the elements, and division and star are the elements on the operator stack. Then comes the subtraction. But subtraction is having lower priority than the topmost element in the operator stack, that is division. So we don't push subtraction here. Instead, we operate the operands with respect to the operators that are available, which are already available in the stack. So first division is performed here. So then division is performed between 45 and 15. So 3 is computed, 3 is pushed into the stack. Again, star is having higher priority than subtraction, so still we don't push minus into that, and instead we operate star on the existing elements by popping out 3 and 2 and then operate on them and push 6 onto the stack. Once 6 is pushed onto the stack, then comes subtraction. Push subtraction into the stack, then push 3 into the operand stack. 3 comma 6 and minus are the elements that are left. Now there are no expressions by the time, so pop out the elements of 3 and 6 and pop out subtraction and perform the subtraction of 6 minus 3, and the answer is pushed into the stack as 3. So like this, at the end we come up with the answer left in the stack, and all the operators are exhausted by this time. No left open, right open brackets are left, no operator is left in the expression. So by this time the evaluation is complete and the answer is 3.